And welcome back to our next podcast on comparative advantage. And let's see, what we're looking at now is what we finished up with on the previous podcast, and that is we were calculating the comparative advantage if we were keeping the amount of time period fixed and allowing us to see the number of units that different people could produce in that fixed time period. What we're going to do in this podcast is we're going to explore same concept just from another point of view, and that is what if we allow what if we hold constant the number of units that can be produced. So we're going to hold that constant at 1 unit, and what we're going to allow to change is the amount of time period it takes to produce that unit. So we're just going to hold something else constant here. So last time we held constant, let's just say that one more time so that we're really clear on it. Last time we held constant the time period, and we changed the number of units. This time we're going to hold the number of units constant, and we're going to see how much time it takes to produce that unit. So what we're saying here then is that person A takes 10 hours to produce a unit of food, and person B takes 2 hours to produce a unit of food. A takes 20 hours to produce 1 unit of clothing. B takes 12 hours to produce 1 unit of clothing. And we want to find who has absolute advantage, who's the lowest opportunity cost producer, who has comparative advantage, and who will specialize in the production of what good. So to do this, we're going to follow our rule that we always follow, and that is we want to get the good that we're analyzing in the denominator and get the denominator equal to 1. However, whenever we're holding the number of units constant and we're bringing this time into play, the amount of time it takes to produce the unit, we now have to take the unit that we want to analyze and start with it in the numerator and allow it to work its way down to the denominator. We're going to take the unit that we're analyzing and start with it in the numerator and allow it to work its way down to the denominator. That is different than this. On this one, where we're holding the time period constant, we could just start with the good we were analyzing in the denominator right away. But now we got to go through an extra step. When we're holding the units constant, then we have to start with the good that we're analyzing in the numerator and let it work its way down into the denominator. So let's do it. Let's say for person A, we're going to analyze food. So let's see. Food takes 10 hours to produce a unit of food. So we're going to put that up here in the numerator. It takes 10 hours to produce 1 unit of food. Then we're going to divide that by how much time it takes A to produce a unit of clothing. So it takes 20 hours to produce 1 clothing. So we started with food up here in the numerator, but it's going to work its way down to the denominator. And the way it's going to do that is we're going to multiply, we're going to take the numerator and we're going to multiply it by the reciprocal of the denominator. So we can say 10 hours over 1 food times 1 clothing over 20 hours. And so then what's going to happen? Well, the hours are going to cross out. So these hours here are going to cross. And so when those hours cross, I'm going to be left with what? 10 times 1 clothing is 10 clothing, divided by 1 times 1 food times 20 is going to be 20 food. So notice we now have what we wanted. We said we want the good that we're analyzing, in this case food, we want the good that we're analyzing to be in the denominator, and we got it, right? And we did it by starting with it up here in the numerator. That was the key. And then it worked its way down to the denominator. And so now we just got to get that over 1. So that's going to be what? Well, it's going to be 0.5 clothing over 1 food. 0.5 clothing for 1 food. So every time A produces a unit of food, he gives up half a unit of clothing. Let's do that for clothing for person A. Let's do this for clothing. So now we're doing clothing. So we want clothing to be in the numerator and work its way down to the denominator. So let's see, we're just going to take 20 hours to produce 1 unit of clothing, divided by the 10 hours to produce 1 unit of food, and multiply by the reciprocal again. So now we're going to get 20 hours over 1 clothing times the reciprocal. So now it's going to be times 1 food over 10 hours. And my unit hours is going to cross, just like before. Sorry. Get rid of that. So we're going to end up with my hours are going to cross. So that's going to be equal to 20 times 1 food is 20 food. Over 1 clothing times 10 is going to be 10 units of clothing. And so we got what we wanted. We got the good that we're analyzing in the denominator. It started in the numerator, worked its way down to the denominator. And then, of course, 10 divided by 20 is 2 food over 1 clothing. So those are A's opportunity costs for producing food and clothing. So now let's ask what happens for person B. So for person B to produce food, okay, we're going to follow the same concept. The good that we're producing, food, is going to start in the numerator. So let's see, B is going to be 2 hours to produce a unit of food. 2 hours to produce 1 food. Divided by, let's see, it takes 12 hours to produce 1 unit of clothing. Multiply by the reciprocal. So we started with the good we're analyzing in the numerator, but it's going to work its way down to the denominator. How? By multiplying by the reciprocal. 2 hours over 1 food times 1 clothing over 12 hours is equal to, all right, so my hours are going to cross. So I get 2 times 1 clothing divided by 1 food times 12. And let's see, then we have to simplify that. So when we simplify this, 12 divided by 2 is 1 divided by 6, which is this number 1.7. It's actually 1.666 repeating, but we'll just round it to 0.17 units of clothing given up every time that B produces 1 unit of food. And then finally, for our last box down here, we have B producing clothing. So now clothing is going to go in the numerator and work its way down to the denominator. So let's see, A is takes 12 hours to produce 1 unit of clothing. So it's going to be 12 hours over 1 clothing divided by, let's see, for food, it takes B 2 hours to produce 1 unit of food. And of course, so the good we're analyzing, clothing, we want that to be in the denominator. Right now it's in the numerator, but it'll work its way down because we just multiply by the reciprocal of this. So it's going to be 12 hours over 1 clothing times the reciprocal, which is going to be 1 food over 2 hours. Hours are going to cross. So then we get 12 times 1 food. That's 12 food. Divided by 1 clothing times 2, which is going to be 2 clothing. So we got what we want. The good that we're analyzing is in the denominator. That's clothing. And then we want to simplify that because we want to get it over 1. And let's see, so 12 divided by 2 is 6. So we're going to have 6 food given up for every 1 unit of clothing. So now we want to come down here and find our answers. Who's the lowest opportunity cost producer? So the lowest opportunity cost producer of food, well, every time A produces a unit of food, he gives up half a unit of clothing. And every time B produces a unit of food, he gives up 0.17 units of clothing. So B gives up less clothing every time that he produces a unit of food. So we would say that B is the lowest opportunity cost producer of food, because he only gives up 0.7 clothing to make a unit of food. A gives up a half a unit of clothing to make food. And actually, I want to get rid of these. I want to get rid of one of these because I just want to have circles. Let me just back this up here. I just want to circle the lowest opportunity cost producer. So there we go. So B is the lowest opportunity cost producer of food. So let's put that back down here. And then what about for clothing? So A, every time he produces 1 unit of clothing, gives up 2 units of food. And for B, every time he produces a unit of clothing, he gives up 6 units of food. So B has a higher opportunity cost. A has a lower opportunity cost. So we would say that A is a lower opportunity cost producer of clothing. Now everything should pretty much fall into place, right? Because the definition of comparative advantage is that you are the lowest opportunity cost producer. So if B is the lowest opportunity cost producer of food, then we would say that B has the comparative advantage. And we would say if A is the lowest opportunity cost producer of clothing, then we would say that A has the comparative advantage of producing clothing. That's what the definition of comparative advantage is. And then we said that specialization, well, the rule is that you specialize in the good for which you have a comparative advantage. So if B has a comparative advantage producing food, then B will specialize in food. And if A has a comparative advantage producing clothing, then A will specialize in the production of clothing. So the only thing that we're left to do is to calculate who has the absolute advantage. And for that, we go back to this original data up top. Now, don't be fooled by this. On the previous example that you did on the previous podcast, you were looking for a big number here. That was this. You were looking for a big number. Who could produce the most amount of the good in a day? That's what you did on the previous podcast. But now you're looking for who takes the least amount of time to produce a unit. All right? So you actually want a small number in this example because you want to know who can produce the good in the smallest amount of time. So let's see, it takes B only 2 hours to produce a unit of food, and it takes A 10. So B can produce food more quickly. So we would say B has an absolute advantage in the production of food. Look at clothing. B takes 12 hours to produce a unit of clothing, but A, it takes 20 hours to produce a unit of clothing. So we would say that B has an absolute advantage in the production of clothing. So B has an absolute advantage in both, and yet it is still worthwhile for B, because A has a comparative advantage in clothing, it is still worthwhile for B to specialize in food, allow A to specialize in clothing, and then they can trade with each other. So that's our second example of comparative advantage. Hope it makes more sense. This has been Mr. Hagen, and we'll be looking forward to seeing you on the next podcast.